In this video, I'm going to lead you through the process of setting up a Reaction Plan Manager++ solution, or RPM for short. If you're not familiar with RPM, the software is designed to analyze measurement data from a measurement system and give the operator on the shop floor instructions on how to adjust their machine if adjustments are required. The analysis and the software reacts automatically to the measurement system, so the operator on the shop floor doesn't really need to do anything but measure his part, and the analysis takes place and the information is displayed to the operator automatically. The beautiful thing about the software is the engineer can tailor it to his specific process that he's responsible for, and the operator simply follows the instructions. The goal for this video is to get you using the software as quickly as possible. Well, the first thing you got to do to use or set up the Reaction Plan Manager++ solution is to be able to get the data from the gauge. There are a variety of ways you can do this. One way is to just get the data directly from the gauge. Another method is to use the Convert utility. Convert utility is software that we've developed that will take the data from the measurement system, convert it into data that Reaction Plan Manager can consume, and then it sends it to Reaction Plan Manager++. A third way is to use a software package called QC-CALC Real-Time. QC-CALC Real-Time is data collection software developed by a company called ProLink Corporation. The beautiful thing about QC-CALC Real-Time is there's drivers for virtually every measurement system that exists, and there's an automatic export to Reaction Plan Manager. So you can plug this in, set it up, and it'll start pumping data to Reaction Plan Manager++ automatically. If you're not sure how to get the data out of the measurement system, contact us at Becker Quality Solutions or contact your local distributor or sales rep, and they'll help you through the process. The first time you run RPM after installation, you're required to configure the software settings. The software settings determine where solutions are stored, where the data is located at from the gauge, and other settings that determines the look and feel of the software. I've already done that for this particular version of RPM, so I want to get to that screen so I can show you the settings. To access the settings screen, if you click on the About button, this window will appear. Then you can click on the Settings button. That'll bring up the settings window. The first setting is a Reaction Plan repository. The Reaction Plan repository is a folder location somewhere on your local computer or possibly a network drive where it expects to find solutions. There is only one Reaction Plan repository per copy of RPM. So for those customers who have multiple copies in their plant, each copy of RPM requires its own separate repository. The next setting is the trigger directory. The trigger directory is a location where it expects to see data from the gauge or possibly QC-CALC Real-Time. It expects to find the data in this directory location. When it sees that data, it'll react on that data. The next setting is the default data source. There's a list of settings you can choose from. I'm going to configure the export for QC-CALC Real-Time, so I'm going to choose ProLink Export after version 3.4.82. Of course, this would include QC-CALC version 4. You have other settings here that some of them are more important than others. It just depends on your configuration. The three that I recommend that you choose are Show all plans in solution when new data is processed in view mode. This will show you all the reaction plans associated with a solution. Automatically build a solution if one is not available. This one is very important that you check. If new data comes across to the Reaction Plan Manager ++ software and there's no solution associated with that data set, it'll build a basic reaction plan using that data. It's kind of like it gives you a starting point in which you can work from when you're writing reaction plans. The next setting is show reminder when new data is added. This is kind of nice because when it does see new data, you'll see a little window which will pop up in the lower right hand side. There are other settings here too. Display done with document button after processing data. This is useful if you're configuring an operator station. If you're configuring an operator station, you want to make sure that when new data comes, that the operator actually reads the report and acknowledges that he has read the report by hitting a button. That's what this is for. Disable the edit button at startup. This will prevent operators from messing with solutions. And run in background. That's really, again, more for operator station configuration. There's a whole video which talks about setting up and using RPM as an operator station. You also have to set the numeric precision. This determines the decimal precision that's displayed. You have password setup. I can password protect the software. So if when you log in, when you start Reaction Plan Manager, it'll ask you for a password, and if you give it the password, it'll unlock the editing capabilities. Manage operator stations. Again, this is used to set up the operator stations. Once you configure your settings, I'll click on the Save button, and that'll save your configuration. Then I'll click on Done, and now I'm ready to continue. When you start Reaction Plan Manager, you are automatically in the View mode. The View mode is used by the operators on the shop floor. While in the View mode, it's monitoring the trigger directory, waiting for data to appear from the measurement system. Once it sees the data, it'll automatically load a solution to process the data, and then generate a report. This is all done automatically. The operator doesn't have to do a thing but follow the instructions that are in the report. The engineer, on the other hand, will use the edit mode to actually develop a solution. If I want to switch to the edit mode, I'll click on the edit button here, and it will put me into that mode. You'll notice there are buttons at the top, and menus will appear on the right. Now, the way this works is it's a point, click, and configure process. You point on an object you want to edit, configure it accordingly, save it to make changes to that object. Now, nothing is loaded, so it's blank. Let's go back to the View mode and talk a little bit about the View mode. You'll notice there's very few buttons in the View mode, and it's done that way on purpose. An operator doesn't need to know all the tools available to actually work on the solution, so he just wants to see the report. So that's why it's simple. You want something that a walk-up user can walk up, get the information he needs, and continue on with his machines. When you're in the View mode, you notice in the lower right-hand side you've got a green box which says Automatic Data Monitoring is on. This is letting you know that, hey, I'm looking for data. Data collection is set to discard data. This is really a function of the solution that you have loaded. Usually you keep the data. You don't just throw it away. You have the Open button, About, Detail, Summary, Print, and Quick Print. The Open button will allow you to open up solutions. The About button will show you tools that will let you change software settings and other tasks associated with the software. The Detail and Summary are different ways you can look at a report. The detail view is it gives you a slideshow presentation where you can put like a picture of the part and with leaders pointing to the part. The summary view is more of a top-down, here are the instructions and that you need to follow. Let's open a solution and see what it looks like. I'll click on the Open button. A window will appear and it gives us a list of solutions in the repository. You'll pick a solution, click on Open, and it loads it into memory. This particular solution was designed to load in the detail view by default. So here you see a picture of the part, and you'll see dimension items that are pointing to characteristics on the part. The dimension items are very important in a solution. The dimension items really control the instructions that the operator sees. Data will flow into a dimension item based upon certain criteria. It will trigger different types of messages to the operator. So in this example, this pulley clip diameter, our instructions are to adjust tool 2x offset by 0.00008. The pulley snout diameter has an instruction of adjusting tool 1 offset by 0.0007. Down below you'll see tabs. Tabs are different ways of organizing the solution. We only see one tab here, tool 1 and tool 2 offset. That's because this particular solution is designed to hide all the characteristics that are normal. We call it severity level. So you've got normal, warning, and critical severity levels. If I want to, I can check the normal severity level and it'll show you the other tabs in the solution. So if I click on the tool 1 and tool 2 offset, here you see everything is green, everything is good. So the operator doesn't have to react to this. There's no adjustments required. These items here on the left are what we call reaction plans. They're different reports for different items or different machines in this particular case. We're looking at machine A. So if I want to, I can click on machine B. There are no adjustments required, just run the machine. If I want to look at machine E, I can click on machine E. So you pick and choose the report you want to see. If I want to edit this solution, I'll click on the Edit button. We have our tools available to us now. Remember I said it's a point, click, and configure process. So say for example I want to edit this pulley clip position. If I click on this object, this dimension item, you'll notice it's highlighted. Over here on the right, a window appears that has the settings for this particular dimension item. You'll configure it accordingly, hit the Save button. Now in this case, I'm in the detail view. I don't like where this is pointing. I want to fix this. So I can click and drag my dimension item around to improve where it's positioned. So it's a point, click, and configure process. It's really pretty simple. I'm going to go back to the view mode and click on the summary view. Now the summary view just gives you the report from top to bottom. I don't have any pictures, no illustrations. It just gives you the instructions. I'm going to go ahead and check on the normal severity level so I can see all of them, and you just simply scroll through the report. New operators prefer the detail view because it's simpler to understand. Once you're familiar with the report, the summary view just gives you the instructions. So you get to pick and choose how you want the information to be displayed. I'm going to unload this solution in preparation for our next topic. To unload the solution, I can go to the edit mode and click on the new, or I can just click on the About button and it'll remove whatever solution is in memory. I have a manufacturing process producing parts, and I've got a measurement system measuring those parts. And I want to develop a reaction plan manager solution so I can give instructions to the operators of how to keep the manufacturing process running smoothly. Before I can develop a solution in Reaction Plan Manager, I need data. Earlier I mentioned there's a variety of ways of getting data from the measurement system. I'm going to show you how to set up QC-CALC real time. So by default, it will export data automatically to Reaction Plan Manager. To do that, I'm going to start by running QC-CALC Real-Time version 4.0. This will work with earlier versions of QC-CALC Real-Time. I'm going to use QC-CALC 4.0. You have to go to the Export menu selection, click on Export. Make sure the automatic exporting is turned on. See how this is checked? You make sure that's turned on. Then I want to choose the Set Automatic Export Defaults. When you click on that, it'll bring up a window where you're setting up the defaults for the automatic export. I want to first check Force Default Primary Export Settings for all parts. Then I want to go to the Export Format. You'll choose from this drop-down list Becker Quality Solutions Reaction Plan Manager++. The next setting is to choose the path. You need to select the path. This path must match the path that you put in, that you set up for your trigger directory inside Reaction Plan Manager++. The next setting is to enter the file name. To enter the file name, you want the file name to be equal to your database file name. I'll click on the Custom button. It'll bring up this window. And where it says Not Selected, you'll click on the drop-down box, choose File Name, click the Add button, and then you'll type .csv, because that's the type of file that comes across from QC-CALC Real-Time. It'll export a CSV file. I'll then click on OK. The table name, just leave that alone. The next setting is a range of records. You want the newest records in the file, and personally I like to leave this set to 25. So every single time QC-CALC Real-Time exports data to RPM, it'll try to output 25 records or 25 parts. Reaction Plan Manager will manage the parts, so if it knows what data it has read and what data it has not read. I personally like to leave this set to 25. The characteristics to export, you want to leave this set to all in file. The special options you can leave blank. The frequency, click on the frequency button over here, or menu selection on the left. Default output export for the frequency, you want to check the records received. So if we're going to leave that set to 1. So for every record that comes into, every part that's measured and comes into QC-CALC Real-Time, it'll generate an export to Reaction Plan Manager. Exporting requirements, you want to leave this set to always export. Once you have these entries filled out, you click on OK. Now from this point forward, any data that comes into QC-CALC Real-Time, it'll automatically send an export to Reaction Plan Manager. Now to test this, I'm going to minimize RPM, and I've got a training CMM that will simulate parts being measured. Now there is a video which talks about how to use the RPM training CMM. I'm not going to go over that right now. I just want to measure some parts. So I'm going to click on the inspect button and watch what happens. QC-CALC does its thing. Data went into QC-CALC real time. QC-CALC real time automatically sent data to Reaction Plan Manager. Reaction Plan Manager tried to find a solution for the RPM training video data file. It could not find one, so it automatically built a solution for you. Basically what it does is it goes through the data file, and for every characteristic or every measurement that's in that file, it'll create a dimension item with default settings. If I minimize this and look at if I look at QC-CALC real time, you'll see that this is a brand new database or brand new database file. I only have one part in there. If I measure another part, you'll see data flow into Reaction Plan QC-CALC. It's automatically sent to RPM, and you see the second part. So now we are to a point where we can start working on this solution. The settings in QC-CALC real time are set up so that we don't have to worry about it anymore. It's set up so it's going to automatically send data to RPM. So you don't have to do anything more to QC-CALC real time. It's done. Now you can start focusing on writing reaction plans. What is a Reaction Plan Manager ++ solution? A solution has two functions. One function is to read the data from the data source and group it. The other function is to perform an analysis and generate a report. There's a mechanism inside RPM called the data collector, which will let you set up how the data is read and grouped. We call groupings filters. So the data collector sets up how the data is read and filtered. The analysis is handled through a mechanism called reaction plans. You'll set up the logic to analyze the data collected from the data collector and generate the appropriate instructions for the operator through the reaction plans. So your goal in designing a solution is to set up the data collector and reaction plans. We're ready to start working on the development process of our solution. Well, first thing I need to do is click on the Edit button to get to the editing tools. The first step in the development process is to set up your data collector. You'll notice at the top there's a button here called Data Collector. If I click on that button, the right-hand side of the screen changes. We now have tools where we can actually set up the data collection. You'll notice you've got three tabs up here. You've got a General tab, a Filter tab, and a Configure Data Collection tab. Below that, you've got a table which actually has the data that came across from your data source. You'll notice you've got green rows and white rows. The green rows represent header records. The white rows represent part data. And if I look at the rows, you've got nominal, plus tolerance, minus tolerance. And at the top, you've got labels for each one of the dimension items. These are dimensions, 1x, 1y, 1tp, etc. And you've got the nominal value, the plus tolerance, minus tolerance, and the actual data down below. So it's delineated by, the columns are delineated by dimensions. Towards the end of this particular data set, you've got machine, stream, and date. These are filterable items. Remember, when you set up the data collector, you need to set up how the data is read and how the data is grouped, or in other words, how it's filtered. So this is important information. Now, for as far as how the data is read, that is really set up when you set up the software. If it knows the data source, it'll set up a lot of these defaults for you, so you really don't have to worry about them. The thing you have to set up is the filters. If I click on the filter tab, you notice I've got add filter, I've got column and name. So you have to tell it where the column is that contains what the item you want to filter on. So in our case, we're going to filter on the machine. If I click on any cell in this column, which is labeled machine, it'll put an entry into the column. And for the name, I'll call it machine, because that's the name I want to associate with this filter. I could add additional filters if I want. It's just, I'm going to just filter on machine. Now I'm going to click on the add button, it adds the filter. Notice the filter column isn't a reference to the column. It's not AA, it's actually machine enclosed in pound signs with a greater than a less than sign in front of it. This is a variable. Reaction Plan Manager tries to use variables wherever it can so that you're not locked into a specific column which contains the data. So in other words, if machine ended up in some other column besides AA, it'll still find the data. Now you're probably thinking, okay, well, how does this work? I've got a filter set up. What does that really mean? Well, this is how it works. When the data is read from the file, it'll group it, and then it will look for a reaction plan here on the left-hand side. These are a list of all the reaction plans that exist in the system, well, in this solution. If it finds the reaction plan that meets the filter criteria, it'll pump the data to that particular reaction plan. If that reaction plan doesn't exist, it will build a brand new reaction plan and add it to the list, and it'll build it from the template. You can think of the template as like the base reaction plan. All the plans are written based off of the template. Notice you have a blank plan here. Well, the reason you have a blank plan is because when the Auto Solution Builder built the reaction plans initially, there were no filters set up, so it just dumped all the data into this empty plan. You can click on this Process Data button here. It will go through the data that you currently have in this table, and it'll figure out what reaction plans to build, and it'll add to this list whatever the filter combination is. So I'm going to go ahead and do that and watch what happens. We now have a new plan called Machine A. Machine A contains the data for Machine A. If you want, I can delete the blank plan. If I click on the Delete Reaction Plans here, I'll choose the plan that has no filter and then delete it. You also notice you have an offline plan. The offline plan is used to do experiments. So you'll work on your solution and you want to test it. So you can go to the data collector, go to the general tab, check this add data to offline plan for quick check, and then hit the play button, and it'll process the data. It'll ask me how many parts you want to analyze. I'll say 2. And then it'll pump the data to the offline plan, and you can look through it and see if your logic is, if your action plan is providing the appropriate instructions to the operator. Let's switch to the view mode. Notice the offline and template plans are not visible. They're in the solution, they're just not visible when you're in the view mode. Operators don't need to see that. That's really more for you when you're developing a solution. Let's go back to the edit mode and continue developing the solution. The data collector is complete. Now it's time to start working on our reaction plans. A reaction plan is divided into two areas. You have the header area at the top and the viewing area below. It's a point, click, and configure process. So you pick the item in the viewing area that you want to edit, or you pick the header at the top if you want to edit the reaction plan's behavior. So for example, if I want to edit the 1x dimension item here, I'll click on that item. You'll see it's highlighted. And I've got a menu on the right hand side that I can make changes to the dimension item. If I want to make changes to the behavior of the reaction plan, I can click on the header. So for example, if I want to set it up so that by default it hides the dimension items that have normal severity, I can uncheck the severity level here for normal and then save those changes. And now by default in the view mode, it'll hide the dimension items that have a normal severity level. The most important object in a reaction plan is the dimension item. The dimension item is where the data flows into. It's where the calculations are performed. It's where the calculations are compared to rules. If there are any rule violations, it'll display the specific instructions to tell the operator what to adjust, how much to adjust by, and in what direction to adjust. All this is in a dimension item. Since the dimension item is so important, I want to spend time talking about the settings for a dimension item. I'm going to click on the More button on the 1Y dimension. You'll see you've got dimension info, process info, and last run info. Dim info is the dimension information. It talks about type of tolerance type of dimension that you have. It's bilaterally expressed tolerance. The nominal is 0. The plus tolerance is 0.06. Minus tolerance is minus 0.06, etc. The process info represents all the parts contained in a dimension item. We've only measured 2 parts, so you only see 2 parts. Hence, the number of parts is set to 2. You notice you've got the average, max, min, range, standard deviations, CP, CPK, deviation from nominal, out of tolerance, and the correction. Last run info is a smaller subgroup. Right now it's set to 1. So our average is, it's average. There's only 1 part, so the average is actually the location of that part. Max, min, range, standard deviation, deviation from nominal, out of tolerance, and the correction. Now if I want to edit this, I'll click on it, it's highlighted, and now we can go over the different settings. And you have a general tab, nominal tolerance tab, advanced message overrides, advanced output. I'll talk about the advanced tabs in a little bit. Last run reaction and process reaction. The general tab is where you can change general information about the dimension item. For example, if you want to change the name, I can change it here. The type of dimension. Your choices are normal and auxiliary. If I set this to auxiliary, the dimension item will be invisible to the operator while in the view mode. It'll still receive data, it'll still do the calculations, the operator won't see it. Message when no rule is violated. If everything is good, this is the message the operator is going to see. GD&T symbol. I'm going to set this to distance. You can choose a whole list of different dimension types of symbols. Startup graphics, it's set to condensed by default. If I like this, I can change it to detail. We'll go ahead and change it to detail. You have detail, condensed, summary, and none. Summary is similar to condensed, where you have a smaller graphic, but you have the corrections on the right. None, you do not have a graphic at all. You just have the instructions to the operator. The process reset. If I have this check where it says display process reset button when rule is broken, it will reset the part counter when button is pressed. So the idea behind this is if I have this checked, it'll display this button. See this button here, press button if adjustment made. So if the operator presses this button, it'll reset the part counter, and it'll assume he's going to go out and manufacture another part, measure it, and send the data through Reaction Plan Manager again. If the correction was done properly, it should have fixed the problem, and it should go back to nominal. You can check the next setting if you want to reset the part counter for all the dimension items in the document. If this particular dimension item, this particular adjustment I should say, affects all the other dimension items in the process, if you have this checked and the operator hits the button acknowledging he's going to make an adjustment, it'll reset the part counter for all the dimension items. The number of parts to queue before applying a process reset. The next two settings are really more for an automated system. If I've got a queue of parts and the operator is going to make an adjustment, the operator wouldn't even be involved in it. It would be more of an automated system. This number determines how many parts it will pass before it actually performs a process reset. The next setting is number of parts before monitoring rule violations. If a process reset takes place, the number of parts after that, it'll turn off the monitoring until the X number of parts are actually flow through the dimension item. The next section talks about leaders. Leaders is really more for the detail view. You can change the look and feel of a leader. A leader is what points to something on a picture. You can hide it. You can change the end cap. You can change the thickness, change the color. Basically, it's the aesthetics of the leader. The nominal tolerance limits tab determines where the data is located in the table. Notice variables are used in the cell references, and the variables are used in this different items in the sheet on this tab. So the column containing the data is the variable 1y, which is column D. The nominal cell is 1y row 2. The plus tolerance cell is 1y row 3, etc. Target shift. Target shift is a distance from the nominal that you actually want to target for the correction amount. Sometimes you may not want to target your process to the nominal target. You may want to shift it closer to a limit to extend tool life. You can put in a value here and it'll adjust your target. Last run reaction tab. This determines the rule violations and the instructions you want the operator to see for the last run statistics. You can set the number of parts to calculate last run statistics. Let's say I want to change that to 3. I'll change that to 3. The last run correction multiplier. This will take the calculation of the correction and multiply it by this value. So for example, the correction is minus 0.0061, and you see that in the instruction here. Maybe I want to flip the sign of that and cut it in half. Now, sometimes you need to do that for the process. This is tailored to the process. So if I put in minus 0.5, that'll cut that in half and flip the sign of the correction amount, which will change how the instruction is displayed up here. Standard deviation rule. If I can put in a standard deviation value, and if the standard deviation is beyond that amount, it'll trigger this rule violation and show the operator the instructions that are in here. Range rule. It's the same kind of thing. If I put in a range value, if the range is beyond that amount, it'll trigger a rule violation and then display that amount. If I leave this value and this value set to 0, it'll ignore those rule violations. Percent of tolerance rule violation. Here you can set the percent of tolerance criteria for the dimension item. It's set to 80%. You notice you've got a upper tolerance and a lower tolerance value you can put in. Again, it's to try to give you more flexibility and more tools for controlling your process. I may want to control it a little, maybe make the percent of tolerance higher on one side or the other. I don't know. Now, if this rule is violated, you'll see the instruction here, and you'll notice you have another variable reference, the last run correction. The last run correction will replace this variable. You have a whole list of values or variables that you can use to insert into this message. You need to be very specific on your instruction. It may be something like adjust tool comp by the deviation amount, something like that. The out of tolerance rule violation is the same kind of thing. If again, you have a variable in here, and when the rule is violated, it'll trigger this message. As a matter of fact, that's the rule that was triggered here was now a tolerance rule violation. Here it just says out of tolerance rule violation, adjust by minus 0.0061. Maybe I want to say something like adjust tool 1 by and the adjustment amount, something like that. You need to be very specific. I'd probably want that same message in my percent of tolerance rule violation as well. The process reaction is looking at the process statistics, so the process info. The maximum number of parts to calculate process statistics is set to 40. If you can change it to anything you want. If there's more than 40 parts that flow into this dimension item, the parts will start dropping off. So the 41st part will drop off the dimension item. It's a first in, first out kind of a thing. The minimum number of parts before monitoring standard deviation spread. This is set to 30. If you're looking at the process reaction, you're really looking at like CP and CPK. And you really don't want to start looking at the standard deviation spread until you at least have 25 or 30 parts that you've measured. This will control that. So if I don't have 30 parts, it won't try to calculate the standard deviation spread. The number of standard deviations on each side of average used to calculate standard deviation spread. Right now it's set to 0. If it's set to 0, it'll turn it off. If you set it to 3, it'll be 6 sigma. 3 on one side of the curve and 3 on the other side of the curve. Process correction multiplier, that's along the same lines as the last run reaction. The last run correction multiplier. I can put in a value here. If my CPK is bad, you could potentially adjust your way out of it. Standard deviation spread rule, this is really the CP rule. If the CP ratio is violated, it'll trigger this rule violation. If your CPK rule is violated, it'll display this rule violation, this instruction. I'm going to leave that set to 0 for now. I'm going to save the changes to this dimension item and watch what happens. Notice our instruction has changed because we've got the out of tolerance rule violation. Also notice that the correction amount was divided in half and the sign was flipped. Those are the type of settings that you change in the dimension item. If you recall, our last run info, the maximum number of parts setting is set to 3. We only have 2 parts in this dimension item, so our last run info statistics and our process info are going to be the same. As we measure more parts, you'll see the numbers change based upon the number of parts in the dimension item. Let's return to the view mode and measure some more parts. So I'm going to click on the view button. I'm going to save my changes. I'm going to open up that simulator and measure some more parts. Notice, before I measure the parts, notice the dimension items that have a normal severity level are not displayed. That's because the setting that I changed in the header of the document. Let's go ahead and measure some more parts and let's watch what happens. Now you see we have 3 parts. Our last run info has changed because now we have 3 parts, and our process info is also set to 3. Let's measure another part. See the white dot there? We now have 4 parts for the process info, and now you can see that the 3 parts, the three blue dots represent the last run info. So you can see how that works. Now let's say I'm an operator, I'm going to make an adjustment. So I'm going to hit this button to acknowledge I'm going to make an adjustment on this dimension item. See the blue line. The blue line tells you that the part counter has been reset. Right at that point is where the statistics is calculated from now on. Notice up here at the top we have an output events button that appeared. When I clicked on that button, it captured that output event. If I click on that output event, it brings up this window where you can see a log, and I can expand that log to see the details. It tells you the information associated with the dimension item that I pressed, that button I pressed. I'm going to measure another part, and you'll see how that line will move with the data. So now I've got more parts in the system. Notice our process info, we have 1 part, and our parts info is set to 1 part because we put a process reset here. So if you have multiple process resets, you will see blue lines in your graph. Let's go back to the edit mode and talk a little bit more about editing reaction plans. I'm going to click on this dimension item, and we're going to talk a little bit more about the advanced tabs. I didn't really talk about the advanced tabs. You're probably wondering, okay, if I make editing changes to this dimension item, what about the rest of the reaction plans? Do the other reaction plans get updated? The answer to that question is yes. If I make any change to a dimension item or a reaction plan, if I click on the header and make editing changes to the reaction plan, it will affect all of the reaction plans in this list. The exception to that is advanced. If you see the word advanced in a setting, that only applies to the reaction plan you're working on. So for example, if I want to change the message overrides, basically you can override the messages for the last run info and the process info. Clicking on the advanced message overrides tab will allow me to make changes to this one particular reaction plan. The same is for the advanced output. Advanced output is used for writing data files. With Reaction Plan Manager, you can actually open up a output file and write adjustment information into the file. Let's switch to the template plan. Click on that dimension item. Notice we don't have the advanced tabs. That's because you're working with the template reaction plan. The template is really, as I mentioned earlier, the template is used to build other plans, so it really doesn't affect this. The same applies with the offline reaction plan. You're probably thinking, if I have to use the point, click, and configure method to edit all the dimension items in a solution, it can take quite a bit of time. That's a true statement. Now, let me introduce you to another tool called the Quick Dimension Edit tool. If you click on this button here, it'll bring up a screen and it'll list all the dimension items in your solution. I can highlight all of them at the same time and make editing changes to those dimension items. So for example, if I know that all the dimension items, I want to use 3 parts in my last run statistics, I can click on the last run statistics, click on change that value to 3, click on apply changes to selection, and it'll update all the dimension items based upon the changes that you make. Now you have to be careful with this. Clearly you don't want to go in and change the nominal and tolerance cell locations because you're impacting all the dimension items in the solution. Let's go to the General tab. I want to get rid of the process reset buttons. You notice how it turns blue? When you see an item that's blue, that means you made a change to it. I'm going to go ahead and apply those changes. What I also like to do is I'll go and change the GD&T symbol for each one of these. I'll add the true position symbol, the diameter symbols, I can do other things as well. Maybe I want to change the number of parts, the total number of parts for the process reaction. Maybe I want to change that to 35. Say OK. And now I've made changes to multiple dimension items at the same time. When you design your reaction plan, you can organize your dimensions by group. Groups are used to clarify the information and manage your dimension items. For example, let's say I've got the measurement data for a process that controls 3 tools. I could group the dimensions by tools. When you group the dimensions, you can display the groups in the detail view. Groups in the detail view are kind of like pages. So I would have 3 different pages inside the detail view to display that information. Another reason to group the items is to manage the dimension items. So for example, let's say I'm using a reaction plan and it's controlling a process and it gives instructions to the operator to make adjustments to tool 1. The operator knows he's going to make adjustments to tool 1 and cut some more parts. You can design your reaction plan so that a button is displayed in that group, and if he hits that button to acknowledge he's going to make the adjustment, it'll zero out all the dimensions in that group, expecting new measurement data to come in after he makes an adjustment and cuts the part, and it should correct the problem. So groups are used for a variety of reasons. To create a group, it's really pretty simple. The easiest way to do that is to use what we call the dimension organizer. The dimension organizer is this button right here. If I click on that button, it'll bring up a page. I should say bring up a window. You'll see a list of dimensions on the left that are not in a group. To create a group, you simply highlight the dimensions you want to include in a group and then hit a button down here to insert a new group. There are other things you can do in this list as well. I can duplicate dimension items, I can cut and paste, insert new dimension items, things of that nature. So let's go ahead and do that. I'm going to group this reaction plane into 6 different groups, 1 for each hole. So I'll click on the dimensions that I want to include in a group, click on the Insert New Group button. I'll continue to do that for, I'll continue to do that for all the dimensions. And one more. You notice I've got them out of order here, so I can move them up and down, move the groups up and down. You notice when I click on an item here, the window changes, or I should say this area of this window changes. You can make modifications to the dimension item or the group that you clicked on. So let's say I want to change the name of each one of these. So I'm calling it group. I'll call it hole 1, hole 2, hole 3, hole 4, hole 5, and hole 6. If I want to add an image to each group, I can click on the Add button down here and add an image. I'm not going to do that right at this time. So I've got my groups, I at least got my groups organized into the dimension items that I want into each group. I'll say OK. And now you notice my summary page has changed. They're now organized in groups. So I've got hole 1, hole 2, hole 3, hole 4, hole 5, hole 6. If I click on the detail view, you'll notice I've got 6 tabs down here, one for each group, hole 1, hole 2, etc. There are settings that will influence how the information is displayed in a group. Some settings affect how it's displayed in the summary view, and other settings will influence how it's displayed in the detail view. Let's switch to the summary view and talk a little bit about how the information is displayed. At the top of the group, you have the name of the group. Below that, you have a list of messages. The messages come from the dimension items. The order in which the dimensions are displayed are equal to the order in which the dimensions are added to the group. If you want to change that, you can click on the group. The window changes, and you have additional settings over here on the right that I can change for this group. The first setting, of course, is the name. I can change that to whatever. The next setting is the message when all the dimensions in a group do not meet severity level. In other words, what's the default message if everything is good? The next setting is the severity levels. Right now, the normal is unchecked. So if there is a message, I should say if there's a dimension that is normal, it won't be displayed in the group. If you want to include the feature name in the message, they're talking about up here in the header block, or in this block here, message block. You check that and it'll include the name of the dimension item. Sequential evaluation. This is kind of a nice one when you're in the summary view. If I have this checked, it will only show you the first message that meets the severity level. So the order in which you have the dimension items added to the group will influence the message that appears here in this message block. Process reset. This is, if I check this, it will include a button here which the operator can press to acknowledge he's going to make an adjustment. I mentioned this earlier when I introduced the group function, the group feature. You may have a situation where you want the operator to actually follow the instructions and make an adjustment. He can press on this button and it'll zero out all the dimensions in the group, because whatever he's adjusting is going to influence all these dimensions. I can add a picture to the group. This really applies to the detail view. I'll talk about that in a little bit. And the rest of these menu selections, the rest of these settings really are pertinent to the detail view. Now once you're done filling this out, if I click on the Save Changes button, you'll notice for machine A, I now only have one message in the message block because I've got the sequential evaluation checked. You also have the press button if adjustment made. That button is displayed because there are some dimension items that fall within the warning and the critical criteria. If we switch to the detail view, we don't have a message block, so that information is not displayed. However, we do have a button at the top. Press button if adjustment made. The detail view offers a way to show the report in a very easy to understand way for the operators. You can include images with dimension items with leaders on them pointing to items on the image. So how do we set that up? Well, the first thing you have to do is organize your dimension items into groups. A group equates to a page inside the detail view. So in this example, we've already done that. We've got holes 1, hole 2, hole 3, 4, 5, 6. I want to focus on hole 1. The first thing I want to do is add a picture to the group. To do that, I'm going to click on the Add button here under Picture. I'll click on Add. It brings up this window. Now, the way it works is you will add images as resources to your solution. And you can just reference those images. So I'm going to click on Add Image. And I've got an image I want to use on the desktop. We'll use this simple holes image. Then I'll click on that and say Open. And that will add this image to this group. Now I also want to change the background color. I'll change the background color to this purplish blue color. You can also change the size of the image. I can I can adjust the scaling of the image. I'm going to leave it set to 1 for now. I'll click on the Save Changes, and the image was added. Now, it's simply a matter of clicking on the image or the object and dragging it around. I can click on it and drag it around. Click on a dimension item, drag it around. Now you'll notice the dimension item has a 5th little circle. That 5th little circle right here is the leader. So if I click on this, I can just simply drag the leader around and have it point to wherever I want it to point to. Now, I want to add this image to all the groups. So I've only been working on hole 1 right now. So if I look at hole 2, there's no image there. Now I can go to hole 2 and go through the same process, but I'd rather add the images to all the groups at the same time. There's another tool available to you called the Quick Group Edit. It works like the Quick Dimension Edit, where I can select multiple groups at the same time and make editing changes to it. So I'm going to click on the Quick Group Edit. I've already worked on hole 1, so now I want to work on holes 2 through 6. Let's go ahead and we'll do sequential evaluation. We'll add the process reset button. Now I'm going to add that picture resource. When I click on that, you'll notice our picture resource is still there. I'm going to click on this and say open. That will add it to each one of the groups. I'll change the background color. Apply those changes. Say OK. Now if I look at hole 2, hole 3, hole 4, etc., they all have the images in there. One problem you will encounter setting up the detail view is the space. When you're in the edit mode, you have the buttons up here at the top and you have the menus here on the right side, so you can change the individual objects that you click on. Well, that's not really how the operator is going to see it while in the detailed view. You can click on the Detail Edit View button right here, and that will hide all the editing buttons, and it will give you some tools here on the left-hand side where I can now make editing changes to the group. You've got Edit, Containers, Lock Leader, Arrange Cascade, and Arrange Square. Edit will let you edit the properties of each object on the page. So if I want to change the picture, for example, or possibly change the scaling, let's change the scaling to 0.8. I can do that here. If I want to make changes to the individual dimension items, I can do that here. When I'm done, I'll say OK. You notice my image shrunk a little bit. But here, you know, I can drag things around and I don't have to worry about the windows, the menus popping up, the menu selections to edit the properties of the objects. So now I can really focus on moving the dimension items around and making the images or the group look good. I'll talk about the containers in a minute. This lock leader is a nice feature. If I lock my leader and drag objects around, you'll notice that the leader for the dimension items will move with the image, and vice versa. If I move the dimension items, you'll see that the object or the leader stays fixed. I'm going to unlock that right now. The arrange cascade and arrange square are useful as well. If I've got a page that has 50 dimension items on it, it may become difficult to try to locate the dimension items and drag them around. I can do arrange cascade, and that will arrange them in the upper left-hand corner to the lower right-hand corner. And it's easier to identify where they are, and then I can start dragging them around. Arrange square is another nice tool. If I arrange square, it will arrange the dimension items or the objects on the page around the image in an equally spaced way. Again, if I've got a lot of dimension items, this is a very useful tool because it spaces the page more evenly. This particular page is for hole 2. I know that hole 2 is this feature here. Now I could simply drag each dimension item and point that to hole 2. I mean, that's one way you could do this to show the information. By the way, I don't know if you noticed, but when you drag it around, you'll see a blue line, a blue alignment line appear. That's it's a tool that helps you figure out the spacing. Now, the problem with this approach is I know that all of these dimensions are for this particular feature. I'd rather put all of these dimension items into a container. A container is nothing more than a matrix that holds dimension items, and then I can have one leader pointing to the feature. So to set up a container, you simply click on the containers button. That'll bring up this window, and then I'm going to select all of the dimension items in this on this page, and I'm going to click on Insert New Container. This will put the dimension items into a container. Now, a container, you can have a header with a name and a GD&T symbol. The orientation describes the order in which the dimension items are placed in the container. In this case, I've got it checked to vertical, and you can put in the maximum number of dimensions along the orientation axis. So if this is set to vertical and this is set to 4, it'll place 4 dimension items in a column, and then if there's more than 4, it'll add another column. And I can also include a leader here, and I can change the color of the leader if I choose to. So I'm going to call this container hole 2. And I'm going to add a position GD&T symbol, and I'm going to check on show header. Now when I say OK, watch what happens. It placed all of the dimension items into a matrix. Basically it's a 1x4, 1 column, 4 dimension items deep. And it has its own leader, so then I can just simply drag this leader to hole 2. Now there are different ways of designing your containers. Let's go to hole 3, and for hole 3 I'm going to set up the container so that it's a horizontal container. This particular feature here is hole 3. So I'll click on the containers button for hole 3, select all of them, insert a new container, change the name to hole 3, give it a position GD&T symbol. Now I'm going to uncheck the vertical and leave the leader and the color the same. I'll say OK. Now this time it placed all of the dimension items horizontally. If you want, you can mix it up and maybe make a 2 by 2 grid. I'll do that for hole 4. Go to containers, select all, insert new, call this hole 4. Oops. Give it a GD&T symbol. Now I'm going to leave this set to, no I'm not, I'm going to change, I'm going to make this horizontal, and I'm going to enter the number 2 for the number of dimensions along the orientation axes. And what this will do is it'll take the X and the Y, put it into a row, and then put the true position and the diameter in a second row. Yeah, I probably should change the size of the picture, make it a little smaller. I'll go to the edit. By the way, notice the box next to each dimension name here. That's telling you that the dimension is part of a container. You'll see that from time to time in the software depending upon what you're doing. Let's knock this down to 0.8, say OK. Makes it a little smaller. And I can drag it around and make it look pretty. Let's go ahead and set up hole 5. I'll add a container. Hole 5 is down here. Insert new container. We'll call this hole 5. We'll give it a header. I'm going to make this horizontal, leave the arrow alone, say OK. Drag this up here, drag this down here. And we'll lock our leader, drag it around, see how that works. You can also, you also have buttons that'll let you zoom in and zoom out as well. So when you're in the detail view, you notice you got zoom in, zoom out, auto scale, and select a box. Zoom in will take you this way, zoom out will take you this way. Auto scale will do this. Select a box, I can pick a box where I want to see. So you have tools that'll let you navigate the graphics area. Let's go ahead and do hole 6. Hole 6 is down here. We'll add another container. Make this horizontal. Hole 6. Give it a header. Leave the leader the same, don't change the color. And I think you get the idea. Let's drag this around. If I click on the return to normal edit, I'm back to my normal editing tool. So if I click on this, you'll see the menu on the right hand side to let you make changes to it. Now notice when you're not in the detail view, if I click on the container, you're editing the container. I can't get access to the dimension items. I have to go back to the detail view and then edit it this way. Let's return to the normal edit. Let's save the solution and go to the view mode and see what it looks like. Now I never did do hole 1. Hole 2, hole 3, hole 4, hole 5, and hole 6. If this was a real application, I probably wouldn't have my my 6 holes organized into 6 different groups. I'd probably put it all in one group, and I would condense some of the dimension items so I could save on space if I were in the detail view. So I'm going to switch back to the edit mode, and I'm going to redo this so that all of the dimensions are in one group and set it up accordingly. So first thing I'm going to do is go to the dimension organizer, and I'm going to remove all these groups except for hole 1. And I'm going to call this 6-hole pattern. And I'll just call it hole pattern. So I'm going to go ahead and put the other dimensions in this group. I'll start with 2. And then I'll add to the group. Then I'll do 3. Add to the group. Hole 4. Add to the group. Hole 5. Add to the group. And hole 6. So now I have all the holes, all the data in one group. I've called this group hole pattern. So as you can see, I've got a mess here. I need to clean this up. Well, the first thing I want to do is I want to take the linear dimensions and I want to reduce the size. I really don't need the graphs for the linear dimensions. I really just need the true positions because that's where the instruction is going to occur. So I'll use the quick dimension edit, and I'll select all of the X's, and I'll change the startup graphics view to none. Do that for all the Y's. And I'll change the instructions here too. If there is no adjustments, I'm just gonna display the deviation to nominal. And I'll do that for all the X's. So now I've reduced all my linear dimensions so that they no longer include a graph. And I have them all organized into one group, hole pattern. So now what I'd like to do is I'll switch to the detail edit view and I'll start building my containers. Now before I was including the header and the GD&T symbol. I'm not going to do that for each container. I'm just going to place them into a container. Now I'm going to do it in a different way. I want to do it in a 2x2 grid. So I'll start with 1, insert a container, then 2, then 3, then 4, then 5, and 6. Now, I'm not going to really be concerned about the container name or the GD&T symbol because I'm not going to show a header. But what I am going to do is I'm going to change it so it's each one of them, the orientation is horizontal, and it's going to be a 2x2 grid. I'll leave the arrow alone. I'll do that for the 6, hole 5, hole 4, hole 3, and hole 1. So I now have all the holes in containers, the 6 holes. I'll say OK. And here you can see I've got all the containers distributed or randomly placed in the group. Now here is a time where the arrange by square is very handy. I can click on arrange by square and it rearranged my hole pattern accordingly, my holes, my containers accordingly. The one problem with this is they're kind of out of order. I mean, it starts in the upper left-hand corner and distributes the containers equally, about, starting in the upper left-hand corner, going in a clockwise fashion. So really, I want this to be 3, 2, 1, 6, 5, and then 4. So the order in which you have the containers listed here will dictate the order in which they appear when you do the arrange by square. So I want to start with 3. I'll move that up to the top. Then 2. Then 1. Then 6. Then 5. Then 4. So now, I'm going to shorten these up so that I can actually work on them and they're not pointing out in space. Now if I arrange by square, I've got 3, 2, 1. Oh, I've got lock. I had the dimension items locked. 3, 2, 1, 6, 5, 4. So I've got them right. Now it's just a matter of cleaning it up. Here's 2. Here's 3. Here's 4. Here's 5. And finally 6. I can actually reduce the size of the image even more. I'll go to Edit, change the scaling so it's more like 0.7. And then arrange by square again. I'll unlock it this time. And it makes it even a little easier to read. So you can see it's pretty simple to set up the detailed view. Let's go back to our normal edit. Click on the Save button, then go to the View mode, and you can see what it looks like. I mean, you could space it out some more if you want and fine-tune it. It's entirely up to you how you want to manage it. Now, one other point I want to tell you about the detail view. The scale to fit feature is kind of nice because you can set it up so by default you see the whole graphics. Now, if you want to make that by default, when you're in the edit mode, click on the detail view, click on the machine A, the reaction plane you want to affect, check the scale, and click on the others to make sure that they're checked. If you check on the template, that'll become the default, and so if any new plans are created, they will the scale to fit will be checked. So if we go to view, you can see that it's by default it's scale to fit. And if the operator needs to zoom in to get more instructions, he can uncheck it and then simply select and then zoom in if he wants to see it even closer up. As you can see, setting up the detail view is really pretty simple. In this video, you learned how to configure the software defaults, the view and the edit modes, how to set up QC-CALC real-time automatic export defaults. So the data will flow from QC-CALC real-time to Reaction Plan Manager++ automatically. Solutions, the data collector, reaction plans, groups, and how to configure the detail view. There are other topics we'd like you to explore in Reaction Plan Manager. Managing variables. I mentioned in the video that Reaction Plan Manager tries to use variables wherever it can. Sometimes there are conflicts in the variable names. There's tools inside Reaction Plan Manager which will help you identify these conflicts and how to resolve them. Links. Links are very powerful. Links allow you to share data between dimension items, and you can create new dimension items using links. An example, I've got a process where I've got two tools, tool 1 and tool 2. If I make an adjustment on tool 1, it'll impact tool 2. I probably will have to adjust tool 2 as well. With links, you can model that. If an adjustment is recommended on tool 1, data is shared with a dimension item for tool 2, and it'll give the instructions to the operator of how to make those adjustments. You can also do custom calculations using links where, say for example, I've got 5 dimension items and I want to run it through some sort of math equation to generate another dimension item. I can model that using links. Very powerful. Configuring RPM++ to analyze hole patterns. There's another application that we offer called the bulk pattern analysis software. The bulk pattern analysis software will take a stream of parts and it'll allow you to plot the hole patterns. There are tools within that application which will let you use least squared fit calculations to optimize how the adjustment should be done, how the adjustment should be performed. Well, you can invoke that application from within Reaction Plan Manager++. With a click of a button, you can pull up the bulk pattern analysis will start, and it'll pull the data from the RPM++ solution. Operator stations. Often, the information is not really used by the inspector that's inspecting the parts. Really, the information is used by a machine operator out on the shop floor by his machining process. Well, you can install Reaction Plan Manager++ on a computer by the manufacturing process, and it'll receive data from the inspection station in the lab. So the inspector can inspect a part, the data is pushed out to the operator station, and the information is automatically calculated and displayed and calculated for the operator on the shop floor, and he can make his adjustments to his machines accordingly. What's nice about this solution is the information is at the manufacturing process, and the operator can pull it up anytime he wants to. There's no printed reports. He just uses the software to give him that information. Importing solutions. If I'm an engineer and I'm designing a solution in Reaction Plan Manager, I don't want to bother the inspection area, the inspectors. So I can develop the solution at my computer at my desk, go to the inspection station, and then import that solution to update the inspection station Reaction Plan Manager. Writing data files. If I've got an application where I want to upload data to the manufacturing process, or the machine rather, you can design your solution to write data files which contain the adjustment values. You can then upload that to your machine. Well, the writing data files video will show you how to generate data files. If you're not sure of what you need to learn, or you have questions, you can visit www.beckerqualitysolutions.com to get more information.